For the next graph, we're going to do the scatter plot. So we're going to do the height versus the standing long jump for the males first of all. So I'm just going to highlight, including the titles, these two variables, continuous variables, which allows them to be put on a scatter plot with good scatter because they are continuous. So they're continuous data is data that can be put on a number line and has actually got lots of in-between values. That might not be 163 there, that may actually be 163.1492. So the continuity means that it can be any measure, so measurement values usually. So anyway, we've highlighted the two variables that we want to plot in a scatter graph. So we're going to insert, and the recommended chart is actually here. So we're going to go to the scatter plot that has not got any lines in between it. So that's pretty good for us. I'm just going to move it out the way of the data just to work a little bit clean in the spreadsheet. So I'm going to put it down here, and now I'm going to tidy it up and make sure it is all looking good. So the first thing I'm going to do is, in the quick layout, maybe I'm going to choose a layout that has all the right titles and shows everything that we want it to show. I don't want that many values, so we're nearly there. And it's got a trend line in there for us. So what I might do is use this one, and I'm going to get rid of the legend. It's spread it out for us. I'm going to choose to hone in a little bit on these axes. So I'm going to cut out the white space here by chopping this up at 100 and 100 there. It's going to be okay so long as we do the same with the other graph that we're about to do. So over here I'm going to, perhaps I'm just going to select the data again. I'm going to edit it, and for the Y values, the X values here, be a little bit careful. I want to put that it's male female, but I might not end up doing a very good job of that. So I'm just going to do that a little bit manually, which means that where is the title here? That particular series is my Y-axis, and it's the second, or the data on the right that I selected over here. So that one is going to be the actual jump, the standing long jump. And the units in centimeters. And this one here was the height. So this axis here, I'm going to call it the height. That was also in centimeters. And up here, I'm going to give the graph a title, and we can normally title it as the Y versus the X. And we write the Y first. So it's sort of right, Y, this one versus that one, like an L, this versus that. So standing long jump in centimeters versus height. Now the idea here is that this one here is the independent variable, or the predictor, and this one is the response on the Y. That means that this one here determines that one, or can be used to predict that one. So we can't change people's heights, but perhaps the heights is the thing that affects their jumping length. I'll put this in a nicer straighter part. Now I'm going to do that little truncating thing that I talked about, where we're going to get rid of the, just trying to move this little rat bag off to the side here. It's kind of jumped in the way. Okay, I'm happy with that. So I'm going to cut this white space out here in the corner. So I'm going to cut this to 100 and cut this axis to start at 100. So starting with this one, I'm going to come down the bottom here, and so it highlights the axis values. I'm going to right click, and I'm going to go format this axis, and the minimum I'm going to start it at 50, and I'll leave it at that. And that was that one, and do the same one here. We're going to format this axis, start that at 50. Oh yeah, it's done that for us. So it's this one here now. I want to do the same. I'm going to format it to start also at 50. And that's good to go. Yeah, so what that's done, it's blown into it a little bit. Did I say 50 or 100? Let me go 100 because I've still got a white gap there that I don't like. I think I meant 100, so I'm just going to come back in and change it. And this one the same. So I don't think anyone in this sample was shorter than 100. Your sample might be different. You might have some shorter people in your sample. So remember that they're all different random samples. I'm pretty happy with that. I'm going to leave that here. Now remember, this was the males. So I'm going to put a little addition to my title and go males. Cool. Okay, I'm going to do the same thing all over again for the females. So I'm going to highlight them, the two data to do my scatter plot. So now dealing with bivariate data. Before we were dealing with one variable, which was just the jump, and we had the two groups. Now we've had the two groups still, but each group has two variables that we're checking the relationship between the height and the jump length for each group, for each gender group. So this is called bivariate data. So now we're going to insert the same scatter plot. Boom. And I'm going to copy the chart title that I had with the other one. So it was standing long jump in centimeters versus height, also in centimeters, females. Double click on, highlight with the left mouse and then right click to format that axis so we can begin at 100 so we don't have the white gaps. And do the same here. Now by making sure they're both starting at the same place, I'm not distorting one graph over the other. So I'm not changing the male or the female visually. You can't really change the graphs anyway because they're plotted with the numbers that are there. And put it beside them there. But sometimes visually you can distort. And remember we talked about making sure that we weren't doing those things to make false or misleading claims, including in our own report. So you have to do an evaluation on that also. So both of them, anywho, start at 100 and go to where they need to. This one goes a little shy of 200. It's 180. So what I'm going to do is I'm going to force that scale to go maximum of 200, which is what the boys one is doing. The only reason I'm doing it is I don't want to blow it up so it looks different to the boys, and I don't want that to be a scale issue, something that I've done. So I'm going to square off those scales so they're exactly the same in both graphs. Just to get rid of that, and they kind of are. What do we notice? We sort of notice for this data there seems to be some differences. Some of the differences could be because my graphs are not exactly the same size as each other. I notice this one stops short and there's a bunch of white gaps here. I do notice that there's linear. I notice this is really scattered and not a strong relationship, whereas this one's strong. But they're both positive. They're both linear. This one could be sort of curving out. It could be a curve. But I'm going to say it's linear with a lot of scattered, especially down this region under the 140s. Now, next thing I'm going to do to make the analysis stronger is I'm going to click, left mouse click on the data, any of it, right click, and I'm going to add a trend line to the male one first. It's linear. I'm going to scroll down the bottom and I'm going to put the equation on the graph in the R squared. I usually come out here and I usually blow it up to make the font bigger so I can see it better. Happy with that. And then on this one here, I'm going to do exactly the same. So I'm going to select the data, kind of right click and add the trend line through all of the data. It's also linear, and I go down the bottom to put the equation and the R squared on the graph. Come out of there, put this in a little bit of a clearer place to read it and blow it up. So I've got two sets of equations for the male and the female. And the reason I've done that is I can compare the values in the equation. So this one here for the males. So that's good to go into the report. You can copy those and paste them in. I'll run some more videos, but I just want to show you that this one is 0.9 of the X plus 18 centimeters. That means the Y, the jump, equates to 0.9 of the person's height, so 90% of the height plus 18. This one here is 0.57 of the height plus 56. So that 56 means we start higher. The y-intercept is higher at 56 if we hadn't truncated this graph. So we have a 56 advantage, but the slope or the gradient is 57% of the height, or 0.57 of the person's height. So it's shallower, it's not as steep. I'll talk a little bit more about that later. It might be that you want to put the scales back to 0, 0 to actually get those looking good. So what I can do, I'm just going to show you, is visually I quite like those graphs, but I'm going to copy that guy there and put him down below. And so it's a copy of the previous graph, and I'm just going to edit down here to make the chart go back to that 0, 0. So I'm going to basically try and auto, or I'm just going to manually do that there. Done. Right click, format that axis, and I'm just going to put it back. So I've got two versions of it and I can pick the better one, but I just wanted to show you that you can easily change things, copy them and change them up. So I can kind of see some details there. Do the same with the female. And I may choose to put these ones in the chart. One way you can do it is you can move the chart into a new sheet, click, and then if I head back to the data sheet, I can move that chart into a new sheet. Because sometimes when you copy these sheets, they're a little more proportional. I don't think so in this case. I think they're just as distorted as they looked back in the data sheet. So I'm just going to put them back, right click, and I'm going to move or copy. I'm going to move it back to the data sheet. To sheet data. Okay, and I'm going to take chart 1. Move a copy. I'm going to choose not to copy but to move it to the data sheet. Okay, and if I head back to the data sheet, it hasn't actually moved it. I'll fix that later.